In the last video, we talked about pre-training, fine-tuning, and reinforcement learning with human feedback, the 3 steps to build an LLM. But here's something weird that surprised everyone. When we make these models bigger, more parameters, more data, they don't just get better gradually. They develop capabilities that were not programmed before. And Google researchers documented this step by step. They took the same architecture, the same model, and increased gradually the parameters. So at billion parameters, the model couldn't do math. At 10 billion parameters, the model still couldn't do math. At 60 billion parameters, the model suddenly could do math, and it was not just gradually better, but it went from 0 to almost perfect math, just like a switch. And that happened also with translating languages or developing multi-step reasoning or detecting sarcasm. These abilities weren't programmed, they weren't in the training step, they just appeared and at scale. Researchers call this emergent capabilities, and this is the reason foundation models are very different from what we've seen before in AI. So what makes a foundation model a foundation model? And there are 2 steps. 1, scale. We don't use thousands of examples, we use millions, billions. GPT was trained on a huge chunk of internet. Our model, EcoJEPA, was trained on 18 million heart videos, the largest data set, eco data set nowadays. Second, it learns without labels. Nobody annotated the 18 million videos. Nobody labeled the internet. The model teaches itself through something called self-supervised learning that I'm going to talk about in my next video. You'll never label a billion of examples, and you don't have to, because if you train the model at scale, you get a foundation. Basically, a general purpose model that's understanding the world and then can be trained on any task. And I saw this emergence firsthand. When we trained EcoJEPA on 18 million eco videos, we never taught it anatomy. We never labeled a single heart structure, but when we visualize it through something that's called attention, where the attention focuses, we saw that the model focuses on the heart chambers or on the valve locations or on the wall motion pattern on its own. We train it also on adult hearts, and we wanted to test it on pediatric data. So different sizes, different proportions, and it worked perfectly without any additional training. The foundation basically transferred without teaching it about anything about heart. But at the sufficient scale, it figured it out. So that's what a foundation model is. Enough data, the right training approach, and something unexpected happens. The model basically develops an understanding that nobody explicitly programmed it to. Now, whether this is interesting to you or it terrifies you depends on the level of understanding of these models, and honestly, that's why I'm doing these videos. I'm Theodora. AI in about 60 seconds. Subscribe for more.